So here we go with 1.4b as in boy from intermediate algebra. And we finished with property number 6, where we were subtracting exponents when we had division signs or fractions. And we're going to look at two different situations with exponents that we run into. One is with the number 1, and one is with the number 0. So first of all, let's look at this. Whenever we have an exponent of 1, it always equals just the x. So you assume that there's a 1 there, but it doesn't really come into play a whole lot unless you run into something like this. Because now that equals x to the 1 minus 3. So another example is, what if we had nothing up there? Well, to know that if nothing is up there, you have an assumed 1, then you can actually do this. Because if there's nothing up there, it's not a 0. Because how many x's do we have up there? We have 1. So we have to put that 1 up there when we are going to do some subtraction there. So that tells you that when it doesn't show up there, when it's not written up there, it is a 1 up there. One of the things I want to show you also is the idea of 3 to the 4th power over 3 to the 4th power. What did you learn a long time ago when it comes to fractions when you have the same number over another number? Well, when you have the same number over another number, it equals 1. When we have 3 to the 4th over 3 to the 4th, it equals 1. Nobody has any problem with that. But according to what I told you in property 6, when we have a number on top and a number on bottom, that equals 3 to the 4 minus 2, correct? All right, so let's say that that number on the bottom is the same as that number on top. That would be 3 to the 4 minus 4, which equals 3 to the 0 power. What did we just say any number over itself equals? 1. It also equals 3 to the 0 power. Therefore, if this equals 1 and this equals 3 to the 0, then 3 to the 0 must equal 1. So any number or letter to the 0 power is going to equal 1. Not x to the first, but just 1. The only time that doesn't apply is with that. When you get 0 to the 0 power, that equals 0. So, but any other letter or number, negative or positive, as soon as you put a 0 on it, it equals 1. So negative 327 to the 0 power equals 1. X, Y, Z, 2. The 0 power equals 1. So that makes it easy. Whenever you see that 0 on there, you get 1. So looking at example 11, to the 0 power, 1. You don't have to do anything with this. That 0 trumps everything, and you're done. But what if we have 2x squared y to the 4th to the 1st power? Well, anything to the 1st power is itself. So then we're done with that there. All right, let's try a couple of examples. Top of page 49. Let's go ahead and try example number 12. We've got x cubed, and we're going to take that to the negative 2. And then we're going to take x to the 4th to the 5th power. And then we're going to put that over x to the negative 2 to the 7th power. So here's the best way to do that. Let me make my 7 a little bit more 7-ish. I have a tendency to make them look funny. Being left-handed does that sometimes. Okay, so the first thing we're going to do is we are not going to move our letters in different, or our stuff in different positions because of these negatives yet. we're going to wait to the end and see if we end up with any negatives before we do that. So what we're going to do is we're going to use the power rule. And because these are at different positions, we're going to write that as x to the negative 6. We're going to write that as x to the 20th. And we're going to write this as x to the negative 14. Okay, now we're going to remember in a lesson before, this division sign, we do not cross it until we've done everything in the numerator position and everything in the denominator to make it as simple as possible. Then we will go ahead and move things. But until then, we're going to just keep working on the top. So x to the negative 6 times x to the negative, or to the positive 20. And that'll be over x to the minus 14. There's nothing to do with that. So negative 6 plus 20, take the difference between the two numbers, put the sign of the largest number on there. Okay. So we've got a couple different options here in order to keep going here. One was, I told you earlier, and it's still true, that this negative says that this is in the wrong place. So one of my options is to write this as x to the 14th, and I'm going to take this and move it up, take the negative sign off, put it over 1, add those two together, and get x to the 28th. So that's one option. The other option is to take x to the 14th, and because this is division, I'm going to take, remember I take the difference between my exponents, or I subtract my exponents. And I have two negatives, add those together, x to the 28th. So either way is a correct method of doing it. It just depends on what you're most comfortable with, and sometimes what makes the problem the easiest. So 6a to the 5th, b to the negative 6, this is number 13 in the examples, over 12, a cubed, b to the negative 9. Okay, so first thing I want to do is determine if there's anything in the top here that I can do to simplify. There's not. Is there anything here that I can do to simplify? There's not. I can't combine anything. So let's go across the division sign there. So I'm going to look at my numbers, and this is 6 over 12. Now let's look at the a's. A is 5 minus 3. And let's look at the b's. The b's are negative 6 minus a negative 9. Okay, let's leave the 6 over 12 alone for right now. A to the 5 minus 3. 5 minus 3 is 2. B, negative 6 minus negative 9. We'll make those two positives. We've got a negative and a positive. Take the difference between the two. Put the sign of the largest number on there. And we get a 3. So here is our kind of final answer, because we still have a 6 over 12, which reduces to 1/2. 1/2 a squared b cubed ends up being my answer there. All right, let's continue on with some of these practices. 14 is a little bit trickier. We have 4x to the negative 5, and then we have a y cubed. And all of that is in our squared symbol, or in our parentheses, and it's squared, x to the 4th, y to the minus 6, and we're going to take that to the negative 3 power. So again, we're not going to cross that division line yet. Let's do everything on top first, and then we will look at on the bottom and then go over that division line once everything's done. So each of these 4, x, and y are being squared. So let's go ahead and give this a shot. 4 squared is 16. Negative 5 squared is negative 5 times 2, which is negative 10. y cubed squared, which is 3 times 2. Do the same thing down on the bottom. X to the 4th to the negative 3 is going to be x to the 4 times negative 3. Y, negative 6 times negative 3. A negative times a negative is a positive. All right, so right now we have simplified that as much as we can. So let's go ahead and go across the division line and see what we've got. Okay, 16, there's nothing down there to mess with yet, so it's just going to stay the same. My x is going to be negative 10 minus negative 12. And my y is going to be the 6 minus 18. So 16x, negative 10, two negatives give me a positive there. Difference between the two, because the signs are different. What's the difference? 2, the sign of the larger one on top. Same thing with the y. We've got a plus, let's make that into a plus negative. Keep with what we've been doing lately. Signs are different. We take the difference between the two, which is 12, put the sign of the larger number on top. Now, if the book asks you to make all of the exponents positive, then that tells us that this negative, this y to the 12th, is in the wrong position. It should be not in the numerator position with the 16x squared. It needs to move down to the denominator position. That's all that negative means, is it's actually in the wrong place. It should be down there. Now, it can be in the wrong place as long as you tell the reader that it's in the wrong place. Okay, so let's jump to what is called scientific notation. Basically, scientific notation is, again, in math, we try to do things as simple as possible. And one of those is writing very large numbers and very small numbers in a shorter manner. So, for instance, if we have 376 million, that's kind of a big number to write. So what mathematicians have done over the years is they take this number and they put a decimal after the first number. That decimal has to be to the right of only one digit. So 3.76, where is the decimal? Actually, the decimal actually is over here, but we moved it to here. So now you have to tell the reader where that decimal really is, since you're doing it in symbol. So here is the universal way of doing that. So once we move the decimal, we always make a time sign and write the number 10. And then we count how far we move the decimal. 1, 2, 3, 4, 5, 6, 7, 8 times. And that 8 goes there. All that 8 is for is to tell you how many place values we moved the decimal. So then when somebody reads this, they could actually go and say, oh, we moved that decimal 8 places, so let's put it back. So it was here, we moved it 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I know that the number this represents is 376 million. And that's all there is to scientific notation in order to write it in scientific notation or to write it in what is called expanded form when you add all those zeros there. So being able to go back and forth between scientific notation and expanded form is very, very important. Okay, one of the other things too, remember that decimal or that negative sign, it means position or it means the direction. So let's look at 376,000. I said earlier that the decimal is actually right here, but we want to write it in scientific notation, so we moved it. And we always put it times 10. And we moved it 1, 2, 3, 4, 5 to the right. in order to get it back. In order to write it in scientific notation, we moved it 5 decimal places to the left. We moved it 1, 2, 3, 4, 5 to the left. But what this number says, because it's positive, it says in order to move it back to where it's supposed to go, we need to move it to the right. So we moved it to the left, but it's supposed to be to the right. All right, there are some times where you're going to get numbers that are very small. They're less than 1. And rather than write those numbers all out, we write those in scientific notation. So we move the decimal 1, 2, 3, 4. Okay, just to the right of the first number. And then we make a time sign, and then we make a 10. Now the thing is, we moved it the other direction, 4. So because we moved it the other direction, we're going to put a negative sign to show that we moved it the other direction. And that in order to move it back, we have to go to the right. 1, 2, 3, 4. So when the numbers are smaller than 1, we move it in a negative direction. When the number is bigger than 1, it's in a positive direction. And in the middle of page 50, there is a table there showing you how all that works. So let's do a couple math problems that have to do with that. And this is kind of nice. This makes life pretty easy. And they did all this just to make math not only more condensed, but also before calculators made it a lot simpler. Okay, so this is a pretty huge number. This is 2 with 1, 2, 3, 4, 5, 6, 7, 8 times 3 with 1, 2, 3. Okay, so it's multiplying that is what they're doing if you put it in expanded form. Now, if there was an easy way to solve that without a calculator, we want to learn how to do it. So what we do is we take our first numbers, which will always be numbers less than 10. 2 times 3 is 6. Put a time sign, put a 10. Then we look at our exponents. And what do you do when you have exponents that are on the same level? You add them. 8 plus -3. The signs are different. We take the difference, and then we put the sign of the largest number. There's our answer. Or 1, 2, 3, 4, 5, 600,000. So if we multiply this times this, we get 600,000. And we leave the answer like that. All right, so if we have 4.8 times 10 to the 9th over 2.4 times 10 to the -3, that is going to be 4.8 divided by 2.4 times 10 to the 9 minus -3, or plus. So that gives me 4.8 over 2.4 times 10. 9 plus 3 is 12. And then we just divide this out. 4.8 divided by 2.4 is 2. So you can do that without a calculator. It makes life a lot easier. All right, let's try one more with a combination. 6.8 times 10 to the 5th times 3.9 times 10. 10 to the -7. And then we're going to divide that by 7.8 times 10 to the negative 4. Now remember again, we're going to do what we can on the top here first before we cross the line. It makes life so much easier. So let's do 6.8 times 3.9. And so that ends up being, I'm not going to multiply that out. Don't have a calculator handy. So we're going to do that. And then we've got that over 7.8. So you just put all the numbers together. And then we have times 10 to the 5th and 10 to the minus 7 over 10 to the minus 4. All right, so when you multiply all this out and divide it, you end up getting, let me make that a little smaller, we end up getting 3.4. Okay, and what do we get here? 5 plus negative 7. So signs are different. We take the difference between the two, put the sign of the smallest number on there, and that's over 10 to the minus 4. So keep going here, and then we'll be done. 3.4 times 10 to the minus 2 minus a negative 4. Because of the division, we have to subtract whatever this exponent is, and in this case, it's a minus 4. Makes it a plus. And again, we have the opposite signs, different signs, so we take the difference between the two, put the sign of the largest on there, and we just have a 2. So we have 3.4 times 10 squared, and that's it for lesson 1.4b.